Hey, so the purpose of this video is mainly just to quickly go over some core topics that you should know before going into AP Calculus. These topics are crucial as they serve as the foundation of all that will come in your mathematical futures. So now we're going to talk about linear functions. So here's a graph of a line, and this line can be represented by the equation y equals mx plus b. And so this is basically your standard slope intercept form, and m is going to be your slope of the line. And m also can be expressed in terms of rise over run, which is also basically the same as y2 minus y1 over x2 minus x1. And we can see that on the graph. We have the first x, the second x, the first y, and the second y. And we can see that's kind of the rate of change or the slope of our line. Yeah, and so as I mentioned before, this is slope-intercept form, and that's kind of a common form. And there's also point slope form, which is another way you can express, it's kind of the same thing to express a line. It's just y minus y1 equals m times x minus x1. And so basically here you can use this if you have a point that exists on the line and you have the slope m, you can write the equation for a line. And so now we can also say there's a general form that you might not have seen before to express a line, and that's going to be ax plus by equals c. And a, b, and c are all constants. And basically what you can see is that if we rearrange this, it can easily be represented to be in slope-intercept form. So yeah, that's basically it for linear functions. So now we're going to talk about functions in general. And so what is a function? It's really a relationship between two variables, and we generally say, like, those two variables, we generally call them x and y, just because x and y are good letters to use. And the set of all values, the set of all x values that the function can take on is called, we're going to call that the domain. And I'm sure if you remember this from like algebra 2. And the set of all the y values that the function can take on, we're going to call that the range. And so the domain and the range we have here. And that's really describing the function at its core. And so we say y equals f of x for a function because x is an input of y. And so y is the same thing for our purposes as f of x. And also, so some common functions, just here are some examples that you might see pretty frequently in your pre-calculus classes, and maybe and furthermore you're going to see these in calculus as well. And so these are just some functions to remember. We got logarithm, we got sine, we got x squared. All of these are pretty common functions that you'll tend to see. And so those are pretty easy to remember. We talked about this before in previous classes, but what about piecewise functions? I'm sure you have familiarity with these, but just to review a piecewise function, we have absolute value of x, that's an example. And so that's going to take on negative x for x less than 0, and x for x is greater than or equal to 0. And that's kind of just we're kind of taking it apart and representing each part separately. So that's how we describe a piecewise. We're splitting up the parts. And finally, something to remember for calculus is composite functions. And so what do we do when we take composite functions? Well, sometimes we want to take functions and combine them just to see how they work better. And so say we have a function f of x, and then we have another function g of x, and we want to make these functions into a single function. And so the notation we use for that, we use g of f of x. And so that's basically, we're taking f of x and we're inputting it into g of x to make like a compound or a composite function, and we're essentially combining these two functions to make one function. So that's basically what a composite function is. And for an example here, we can see there are some common composite function examples. So y equals x cubed, say that's one of our functions, and then we also have y equals log of x. And so if we want to combine these two functions, we can say that x cubed is f of x, and then log of x is g of x, and we can say g of f of x. Well, what is that equal to? Well, we're basically putting x cubed into the log of x, so we get log of x cubed. That's our composite. All right, so now that we've kind of covered what a general function is, we're gonna cover a specific type of function, and that's the exponential function. And so in calculus, we wanna model things, and we can use these exponential functions to model relationships, and they're good for modeling fast growing and fast changing relationships. So here's what an exponential is. It's f of x equals a to the x, and we have this kind of an exponential. We say it's an exponential function with base a, where a is just a constant and x is our input variable. And so this function can be used to show some interesting real life results. And for example, we have a compound interest exponential, and that's kind of a specific type where we say that future value is represented as the present value times 1 plus r divided by n to the nt power. And this is just kind of a specific type of exponential you'll see in calculus and in the real world. And p is, as we said before, it's kind of present money, and r is going to be your interest rate, and in here is going to be the number of increments that you have, the number of times you compound the interest over an interval. And then t, of course, is going to be your time in years. And so this model is pretty useful. We use it a lot in real life. And in calculus, you can see how it's going to work. And so an exponential will typically look like this, where it rapidly grows. And this is a helpful model to use when we want to understand things in the real world. So it's helpful sometimes to understand relations in terms of a third variable. And so that's where parametric equations are going to come in. And so sometimes we don't want to use just x and y to describe relationships. And we typically do have x and y in like a regular function, but sometimes we can actually use a third variable, and that variable we generally call t. And t can be time, it can be some other external variable that's having an effect on the system. We don't really know what t is here, but it's just a general form that allows us to express relationships in terms of three variables. So we can say that x equals the square root of t. We can say that y equals t, and that's a parametric relationship for t is greater than or equal to 0. And so how do we graph this? Well, it turns out if you have a graphing calculator, we can use pair mode if you have a TI-84 or a standard graphing calculator, but you can also try to convert one of these parametrics into a regular function. And so basically how to do that is you just you plug in x for y, and we can see that y equals t, or the square root of t squared. So then y is going to equal here, y is going to equal x squared. And so it's going to kind of look like that. And so yeah, we can typically transform parametrics into regular functions and graph them like that.